at our last target, target 5B, which is all about what we call regression. Okay, so before this, we've always been looking at one variable stack. We found the mean, we found the standard deviation, but we only really had one list of numbers. Now we're going to be looking at two variable stacks. And two variables really just relate to things. So again, looking at how long someone studied and how long they, and the score they got on their test, right? So these are like points. We plot those points. So how long someone would study, right, that would be like your x-axis, and then what they got on their test, that's your y-axis. We have an independent and a dependent variable. Okay? So a regression is finding an equation, right, or finding a line that fits that data so that we can make predictions off of it. And so a regression, we're really only going to be looking at linear regression, but you can do any type of function. So finding a function that fits that data. Then your correlation is the strength of the relationship between the two variables, right? So how close they actually are to that line that you find. Okay? And you want a strong correlation. Right? That would be great. If you can find that something has a strong correlation, right, you can more accurately predict what the outcome is going to be. Okay, so a strong correlation can either be positive or negative. If you look at this chart, just the closer it is to 1. So the closer it is to positive 1, right, you find it's a strong positive correlation. The closer it is to negative 1, it's a strong negative correlation. The closer it is to 0, right, that's no correlation. Okay, if it's close to 0, it means there's no correlation. So let's look at an example. Yeah. So let's look at these examples, right? One other thing. Our correlation coefficient, you can kind of see it in here. We have all these R's. Right? The correlation coefficient is called the R value, and it's between negative and 1, and it represents that correlation. Okay? And again, you want it to be close to negative 1 or 1. If it's like 0, 0.1, those are bad correlations. It means they're not really related in any way. Okay. So if we look at A, right, A has an R value of negative 0.627, right? Since it's negative, we know this is a negative correlation, and you can look kind of here, so 0.627 is going to fall here. So this is a moderate negative correlation. Kind of see, like, if I draw a line, right, this line would kind of represent, sorry, that's my board. This line would pretty much represent how those lines are correlated, and you can see those points are kind of scattered out from around there. Okay? They're not really close to it. If we look at B, right, well, B is positive, and it's really, really close to 1. So this is a strong positive correlation. Right, and again, if I try and draw a line that goes through all these points, like that, right, you can see all the points are really, really close to that line. So that's really just what a strong correlation means. All the points are going to be like right on top of that line. Okay, so that's a strong correlation. Okay. And for C, well, technically that number is positive, but really it's no correlation. When you're that close to 0, these points aren't really related at all. Okay, so that's no correlation. Again, like, I don't even know how to draw a line through these points. I guess technically, maybe like that, right? None of those points make a line. Okay. So the difference between positive and negative is the slope, right? Positive means as I increase my x, my y increases. Negative just means as I increase my x, my y decreases. Okay. So something we would expect to have a positive correlation, again, studying in your test score, right? We would expect the more you study, the higher your score is going to be. That would be something with a positive correlation. Something with a negative correlation would be If on the x-axis we graph how many absences a student had, and then their grades on the y-axis, right? We assume the more you miss class, the worse your grade's going to be, right? That's going to be a negative correlation, right? As I increase one, the other decreases. All right. So that's what we have for a regression. Then we have something we call a residual. So residual is different than regression. For your residual, the difference between the observed value and the predicted value from, so your residual is the difference between your observed value and the predicted value from the line of best fit. What we mean by that is, let's go back up to where we have these regressions, or these scatter plots, right? So again, this is my scatter plot. My regression is this line here. My residual is the difference between each of those points and this line, right? So I could find, right, each of these points is some distance away from that line. So instead of graphing y, right, my x and my y, I'm going to graph the x and that distance away, okay, how far it is away from what you would expect. That's what we call our residual plot, okay? Your residual plot is so it's different than your regression plot. We have two different types of plots. And your residual plots will look more like these, okay? Residual plots can help us determine if a line is actually a good fit, right? Maybe we don't want to use a line. Maybe it should be quadratic. Maybe it should be exponential, right? We could have all these different types of functions. So we can look at the residual plot and see if it is a good fit. If it's a good fit, it will be symmetrically distributed. So it will just look like a cluster. It won't have a shape or anything. And it will tend to be towards the middle. So middle in both, like if you think about x and y. So middle, completely center. It should also be clustered around the lower single digits. You don't want hundreds, 200s, anything like that. And like I said, you don't really want any pattern. So let's look at some examples. Examples, right? So looking at these, determine the residual plots that confirm the line of best fit. Okay? So we want to choose which ones are a good fit. If I look at the first one, right? It's nice, symmetrical. Those points are kind of just scattered around. There's not really a pattern. And these values are really low. They're all kind of between -5 and 5. Those are low values. So this is a good fit. If I look at the second one, right, if you notice, right, they're all kind of clustered towards the bottom, and then some go up from there. That's a bad fit because they're not clustered around the middle. Not clustered around the middle. Okay. So what that tells me is that a line is probably not the best function for that equation. It could also say that it's really bad correlation, right? If you look at your residual plot and it looks like this, it could just mean there's not really a great correlation. You can't use a line. You can't really use anything, okay? If we look at the third one, again, this one's just kind of scattered around. There's not as many points as there is in our first one, but that doesn't matter. These points are still scattered around. They're kind of near the center. And if you look at our graph, it's all between like -2 and 1.5. It's all between negative numbers. So this is a good fit. Number 4. All right, well, all my points are clustered up in the corner. They are not in the middle. So this one is a bad fit. We don't want that. Because there's a few points that are dragging it down pretty much. And then our final one, right? This is actually a pattern when it kind of looks like it's like starts small and like blooms outward. That is a pattern, so this is also a bad fit. Pattern starts close. And fans out. Right, so they're all really close, and then it just starts going out. That's a pattern, and that's a bad pattern. Okay? All right, that's all we're going to talk about today for the notes. So just regression and residuals. On Monday, we're going to come together a little bit and do some of the calculator stuff that goes along with this. So I'll see you guys then. Have a good weekend.